At the American Geophysical Union conference this week, JPL released rotary actuator telemetry from Perseverance's Rocker-Bogie system, and the numbers are remarkable. After 40 kilometers of Martian traverse, those six-wheel actuators have passed 1 million cycle qualification tests at 0.5 Newton-meters of torque. That's not a press release number. That's an engineering margin that clears the rover for another 60 kilometers to Lac de Charmes, a total traverse that would triple Viking 1's 35-kilometer record from 1982. And here's what the mainstream rover retirement headlines missed. This is the same six-wheel geometry NASA validated 50 years ago. The dust loading, the thermal cycling, the bearing wear. Viking's actuators survived 2,245 sols on hardware we'd now consider primitive. Perseverance is running that same playbook with modern materials. Today, we cut through the budget panic to examine the actual subsystem qualifications extending this mission to 2031. Let's get into the telemetry. The Rocker-Bogie isn't just a suspension, it's a 6-point load distribution architecture where each wheel carries exactly 1/6 of the rover's 1,025 kilogram mass. Social media calls it a car on Mars. It's not. The geometry uses passive articulation with no springs and no axles. Each wheel moves independently through plus or minus 45 degrees of terrain variance. The 6 rotary actuators operate at 0.5 Newton-meters of nominal torque, and that low figure is intentional. Higher torque would cause wheel slip on low-friction regolith. The million-cycle qualification translates to roughly 600 kilometers of theoretical range, 10 times the extension JPL just approved. But here's where the power budget constrains everything. Perseverance's RTG produces 220 watts, and after heating and computing loads, only about 100 watts remain for mobility. That's why drive operations are carefully rationed across each sol. The design philosophy hasn't changed since Viking. Distribute the load, minimize the torque, accept slow speed in exchange for longevity. Viking used the same basic geometry with 1970s brushless DC motors. JPL saw no reason to reinvent it. While the press focused on the health check past narrative, the actual telemetry reveals a more nuanced story. At 40 kilometers, Perseverance has already exceeded Opportunity's final actuator load profile, but the difference isn't mileage. Jezero Crater's basaltic regolith has approximately 15% higher abrasive particulate density than Meridiani Planum. The brake assemblies are still under evaluation, and those brakes, not the drive motors, represent the most likely failure point. When a rover holds position on a slope, the brakes take continuous load. That's where fatigue accumulates. Martian dust averages 3 microns in diameter, fine enough to penetrate seals designed for terrestrial particulates. And seal degradation is logarithmic rather than linear. The first 20 kilometers cause more proportional wear than the next 20. The June 2025 record of 411.7 meters in a single sol wasn't a publicity stunt. It was a stress test at maximum duty cycle, pushing actuators to their operational ceiling to validate the extension. JPL needed that data. They weren't certain. The other factor changing the equation is ENav autonomy. 90% of drives now use onboard path planning rather than waiting for Earth commands. That reduces the latency risk that killed Spirit, the rover that got stuck because ground controllers couldn't see the terrain trap in time. Here's a question for the engineers watching. The Rocker-Bogie hasn't fundamentally changed since 1976. Is that elegant simplicity, or are we overdue for a redesign? I want to hear your take in the comments. Viking 1 was designed for 90 sols. It operated for 2,245. That's not luck. That's a 2,400% margin hidden in the actuator specifications. The popular narrative frames Viking's longevity as survival against the odds. That framing turns engineering into mythology. Viking survived because the actuator margins were so conservative that even catastrophic seal degradation couldn't kill the mobility system. Viking traversed 35 kilometers over 6 Earth years at Chryse Planitia, using the same Rocker-Bogie architecture scaled for a 572-kilogram lander. The dust-loading environment, basaltic particulates, seasonal storms, is directly comparable to Jezero. We're watching the same experiment run twice, 50 years apart. JPL's 1977 post-mission report contains a revealing admission. The actuator margins were significantly underestimated. The hardware outperformed. Estimates by an order of magnitude. That institutional surprise became institutional memory, which is why Perseverance qualified to 1 million cycles against a mission requirement of 400,000. The historical record reveals something counterintuitive about how Mars actually kills rovers. It's usually not mechanical wear. Opportunity died at 45.16 kilometers in 2018, but the actuators weren't the failure point. A global dust storm starved the solar panels, the batteries drained, and the electronics froze. Spirit logged only 7.73 kilometers before a wheel failed, but that failure occurred during extraction attempts after getting stuck in soft regolith, a navigation failure that manifested as hardware failure. Curiosity, still operational after 13 years, has covered more than 32 kilometers on RTG power with significant wheel damage, but functional actuators. Perseverance inherits all these lessons. The RTG eliminates Opportunity's failure mode. ENav reduces Spirit's failure mode. Adjusted driving protocols address Curiosity's wheel damage. The 60-kilometer extension tests whether that synthesis holds. If you want the full Viking mission breakdown, we covered the complete technical history on our Heritage channel. Link in the description. There are 24 sample tubes cached in Jezero Crater right now. Each one represents $458 million in sunk cost, and Congress is debating whether to abandon them. The hot take is that Mars sample return is too expensive at $11 billion. That framing ignores what's already spent. The tubes are on Mars. The drilling, caching, and traverse to deposit sites, that money is gone. The question isn't whether to start Mars sample return, it's whether to finish it. The current architecture calls for an ESA-NASA retrieval, with a 2033 launch and Earth return by 2035. That depends on 3 vehicles: Perseverance, ESA's Earth return orbiter, and NASA's sample retrieval lander. 3 failure points. The 2026 appropriations cycle has flagged MSR for re-scoping, budget language that typically precedes cancellation or indefinite delay. JPL's response is the data we've been discussing. Proving Perseverance longevity to 2031 keeps samples accessible even if retrieval slips. We've done sample return exactly once. Apollo. Those 382 kilograms of lunar samples are still being analyzed 55 years later. The Jezero tubes could do the same, but only if they make it off the surface. While NASA navigates appropriations, China's Tianwen-3 is in hardware development with a 2028 launch window. If CNSA retrieves Martian samples before NASA, it won't just be a PR victory, it'll be a scientific coup. Western coverage treats Chinese timelines as aspirational. The data says otherwise. Chang'e 5 executed lunar sample return in 2020 on schedule. Tianwen-1 delivered to Mars in 2021 on schedule. When China announces a date, assume they're ahead of it. Tianwen-3's architecture is simpler: orbiter, lander, ascent vehicle, and return capsule in a single integrated mission. 1 failure point versus 3. The Soviets demonstrated this approach in 1970 with Luna 16. CNSA studied that architecture extensively. Here's the 12-month forecast. First quarter 2026. Brake assembly evaluation determines whether the 60-kilometer extension is fully approved. Second quarter, Congressional Appropriations decision on MSR rescoping. That's the budget knife. Third quarter, CNSA Tianwen 3 hardware integration milestones. Based on their track record, I'd bet on them hitting their window. Fourth quarter, if Appropriations survive and breaks clear, Perseverance reaches 55 to 60 kilometers total odometry. The mainstream narrative wants you to believe this rover is on borrowed time. The Actuator telemetry says otherwise. 1 million cycles, 0.5 Newton meters. A geometry validated in 1976 and still running 50 years later. The real question isn't whether Perseverance can make it to Lac de Charmes, it's whether Congress will let it. That's the flight briefing. Go for powered descent.